Hey everyone, welcome back. So today we're going to be solving Leetcode 94 binary tree in order traversal. For some of you, this might be a very easy problem. It is actually an easy problem because all you have to apply is in order traversal, depth first search. But the reason I'm making a video on this is to go through what's happening in the backend, right? So of course you'll be writing a recursive call. It's probably 3 or 4 lines, but you really need to understand how those recursive calls are working for you to understand what's happening in the background. Okay, and that would really help you understand trees. For the people who think tree is hard, it's not hard. It's just that you need to understand what's happening in the backend so that you'll be able to make changes to your logic. Okay, so today what we're going to be doing is we're going to be applying an order traversal, and then we'll be tracing the stack throughout the problem, and then we'll code it up. Okay, so this to make you understand how the stack trace is actually working. Okay, so let's begin. So I've taken this input particular thing, and then I've assigned the address as same as a value, just to make it more visual and make it more understandable. Okay, and here I've written the recursive call. This recursive call, if you see, it's nothing but so if you know what in-order traversal is, in-order traversal is nothing but you're traversing through the entire array, entire tree by this approach, right? Which is left node and then right. Left means that you're going to the left node first, okay? Then you're coming to the node, which means that any parent node, okay? And then right meaning that you're going towards the right of that node. That's what this means. And if you see the approach over here also, forget the base case over here. Look, if you look at these three, that's exactly what I've written. So I'm going towards the left first, okay? Then I'm printing the node value, okay? Then I'm going towards the right, okay? The question is asking us to return the list, as in after traversing return, it's asking us to return the list. But while understanding, we'll do it with printing. That's the reason the return type is void over here. And while actually doing it, we'll just give the return type as a list. Okay. Now, if you don't understand what this base condition is, wait. Let me go through the strategies, then you'll get a good idea. Okay. But I'm pretty sure that this is easily understandable. This is exactly doing what we mentioned over here, L, N, and R. Okay. So let me mark this. This will be 1, this will be 2, and this will be 3. What are these 1, 2, 3? These are nothing but the steps. Okay, steps that we're going to follow. Okay, now to the stack, you'll be making a whatever happens is in the main function, when you're making a call to in-order recursion function, what happens is a parent function gets created right in the stack. So in-order recursion of root node. For now the root node is at 62. So 62 is not the 62 is also a value, but 62 is also the address of that node. Okay, now you have the root node. Okay, now what are you doing? This is your parent call. Now is where your actual recursive function starts. Okay, so let me write this. $62K. Okay, now I mentioned 3 functions over here, right? I'll just mention those functions over here, 1, 2, and 3. Okay, so we have 3 functions that needs to be executed. Okay, now what happens? Let's go through the example. Okay, so currently we are at 62K, right? We are currently at 62K, right? We need to go to, what is this thing? It's L, N, and R, right? We need to go towards the left. Okay, we go towards the left, that is 41K. Okay, we're at 41K. Now what I'll do is, when you're at, so okay, wait, you're at 62K, I'm checking is root equal to null. Okay, it's not, because the address is 62K and root dot left is 41K, right? So the address of the left node is 41K, which is not null. So what will happen, I'll go towards the left. Okay, and what I'll do is I'll call the function in order of 42k. This will also have 3 steps. Okay, now I've reached over here. Okay, now again I need to go towards the left. I'll go towards the left. So this will be in order of 23k. Again this will have 1 2 3 steps. Okay, now yeah, so 1 2 3. So I'll be calling towards the left. If you see the left, there's no element to the left, right? It's empty. So what will we be calling? We'll be calling in order of null, right? Because your root dot left equals to null, and that is the value you're passing to the second call, right? Perfect. So now when this value is null, what happens? When this value is null, we have a base case which is handling that. When the value is null, all we are doing is we're just returning. Since this is a void function, we don't have to return anything. We just return it. So what happens? This function gets a vector out of stack, and then it comes here, right? It comes here. Now let me write the output over here. Okay, here is the output. Okay, now it comes here in order of 23. So the first step is over. What is the second step? We have to print. Print is nothing but print root dot value, which is nothing but 23. Second step is over. Now what we're gonna do? We're gonna call third step, which is nothing but root dot write. So we're gonna call in order of root dot write, which is nothing but 28k. Perfect. So this is gonna have 1 2 3, and what this is gonna do is this is gonna again call the first step, that is dot left. Is there anything to the left? No, there's nothing to the left. So this will be calling in order of null. Right, this will be calling in order of null. So what will happen is this will get a vector out of stack, and my first call is over. Okay, the second thing what I'm doing is I'm printing. Right, second thing I'm printing. So my second step is also over. What is my third step? To call in order of write. Here write is also negative. So what we do, we call in order of null. Okay. So what happens here is this function gets called, this gets evicted, and then it comes down to this function. Now third step is also over. After third step, what happens? This also gets evicted. Right? Now it came back over here. Now 23 third step got over, so this will get evicted, right? So third step is also over, so this will also get evicted. Okay, so let me erase all this. Since it got evicted, this is exactly how your stack is also functioning. Okay, so let me erase this. Okay, perfect. Now your stack is clean. Okay, now in order of 42k, first step is over, right? First step is over. Now the second step is to print. So I'm printing 42k, and the second step is over. The third is to call the write of that, which is nothing but 58. So I'm calling in order of 58k. This will again have 1 2 3 steps. Okay, the first step is to call left. So in order of, I'm calling in order of null. Since there's no value towards this is x, null, right? So what happens? This gets evicted, and this comes over here. Now what happened? I'm done with the first step. I have to print, right? So I'll be printing 58, right? Perfect. Now second step is done. Third step is to go towards the one second. Okay, I made a mistake. Okay, the thing is, there's no value towards the right, not towards the left. So in order of 58k, if I have, it will call in order of 57k, right? 57k, because if you see, there's value towards the left but not towards the right, right? So it'll be 1 2 3. This will also be 1 2 3. Now this will call in order of null. right? This will go, then this will go, get evicted. It will come here. Now first step is over, so I have to print 57. Now we'll call in order of null. Again, what happens? Second step is also over. This gets evicted out of stack. Then what happens? It comes down. After this is done, the third step also gets evicted. Okay, so what happens? This is done. Now after this, my first step is done. So what I'll do is I'll print the second step. Then the second step I have to print it. I'll print 58. Okay, now my second step is done. Okay, now what will happen is it'll call the right side, right? So this will be in order of null, right? There's no value towards the right. Perfect. If it's in order of null, this will get evicted out of stack. This will get returned. So now what will happen is third step is also over. Now what happens? This also got evicted out of stack. Perfect. Let me erase this. Perfect. Now 42k. Yeah. Now what happens? I've gone towards the left. I've gone towards the right. Okay. Now third step is also over. This will also get evicted out of stack. This will also get evicted out of stack. Perfect. Now for 62k, which is over here, my first step is done. So I have to go to the next step, which is printing. So I'll print 62k. Now what will happen is second step is done. I'll go to the third step. So this will be in order of 71k. Right? Now this 71k, it has to call, this will have three steps. This will call the left first, which is nothing but null. So in order of null will be called because there's no element towards the left. So what will happen? This will get a vector dot stack. Come here, first step is over. The second step is to print. So I'm going to print 71k. Okay. Now what happens? I'll have to go towards the right. Second step is done. So I'll call in order of 92k. This will again have three steps. First step is to call left. This will basically call in order of left is 78, right? If you see over here, my left value is 78. So I'll call in order of 78k. Again, this will have three steps, 1, 2, 3. If you see 78 has both of them as null, so what will happen is it'll be calling in order of null, right? So this will get a vector dot stack. My first step is over. My second step is to print, right? 78. Minimize this. Yeah, my first step is done. Printed by 78. Second step is done. Third step I have to go in order of null again, because right side also it's null, right? What happens here? This also gets a vector out of stack. It comes down. Third step is done. So what will happen? This will also get a vector out of stack. Now what will happen? It'll come here. First step is done for 92k, right? So I have to print. So I'm gonna print 92. Okay. So I have printed 92. Then what will I do? I'll have to go to the next step. Second step is done, which because I've printed. Third step is what has to go to the right. What is it to the right? It's nothing but null. So this will be in order of null. What will happen? This will get a vector of stack. It will come down. Third step is over. So after third step is over, this function also will get a vector. Okay. Now it has come down over here. Now third step is what which ran. So 71k is what which ran, right? Now 71k also will get a vector. Okay. Now after this will come down here. The third step was remaining. Now this will also get a vector because the third step was the one which is running. After it ran, it got a vector. Now this function call also will get evicted from the stack frame. Now what will happen is after everything is printed, the parent call also will get evicted. So this will be a final output. Okay, let's validate this. There is a website where I took this example from, and this exactly is what the output is. So 1 is 23 and we've received 23. 2 is 28, perfect. 28, 42, 41, I've taken it as 42. Okay. 4 is 57, perfect. 5 is 58, 6 is 62, 7 is 71, 8 is 78, perfect. 9 is 92, perfect. Now we've got the answer. Okay, I really hope you understood how to stack trace it. This is very, very important. I would suggest you to stack trace the problems on your own so that you get a very good understanding. Okay, now let's code it out. Let's have okay, so let's have public, let's call it recursion only, and then let's have tree node of root, comma, of final, let's call it final answer. Okay, now what happens here is, now I have to handle the base case. This will be my base case. Okay, if my root equals to null, then I'll be return final answer. Perfect. Else what I'll be doing, not else, what I'll be doing is I'll be calling a recursion of root dot left, comma, final answer. Okay, then what I'm going to do is final answer dot add of root dot value. Okay, then what I'm going to do is I'm going to return recursion of root dot right, comma, final answer. Perfect. Here all I have to do is have a list of integer and then call it final list equals to new array list. Perfect. Now what I'll be doing is I'll be calling recursion of root, comma, final list. Perfect. Here I mean I have to return, right? So I'll be writing return. Perfect. I've not submitted this problem actually. This is the first time that I'm doing it, so there might be errors, so we'll try to fix them. Okay. Yeah. Okay, can I find symbol root dot right? Oh, sorry. Okay, perfect, get accepted. Let's submit it. Perfect. Okay. I hope you understood the solution, and I hope you understood the stack trace. I would suggest you to do it again on your own. You can take the same example or you can take a different example. Okay, thank you so much.